Well, hello everyone. It's 1 o'clock. Welcome to this Xenon Tech Talk, all about NVIDIA's new DGX A100. So I think a lot of times in the technology industry, adjectives like game changer, revolutionary are highly overused. But I think in this case, when talking about the DGX A100, they're probably not superlative enough. I think when you have a look under the hood at this new bit of NVIDIA, you see how it really does have the potential to revolutionize how people manage their AI workloads. So welcome to the webinar. If you have any questions, please pop them in the chat. I'll be monitoring that as we go along, and there will be time for a bit of question and answer, a bit of discussion at the end. And without further ado, I will hand over to Werner, who will take you through the new DGX A100. Take it away, Werner.
Thanks, John. So let me just share the slide deck here. All right, does it come through okay? Okay, so welcome everyone to the presentation here about the DGX A100, which is really the third generation AI infrastructure. We've been there from the very beginning, working with NVIDIA already on the DGX1, the DGX2, and now the latest iteration, the DGX A100. In this webinar, I want to talk you to a brief introduction about XENON Systems, and then dig into really the new technology that's incorporated and included in the new DGX A100, which are the really revolutionary Ampere GPU architectures implemented in the A100 GPUs. We'll have a look at some of the new innovations which have been implemented, including the third generation Tensor cores, the multi-instance GPU implementation, and how NVLink and NVSwitch are tying this all together in the DGX A100. And towards the end, I also want to look at how we can expand beyond the DGX itself into complete pod architectures, which then include storage and network fabrics, which tie it all together. So about XENON Systems, who we are. XENON Systems has been established in 1996 as an Australian company here, founded in Melbourne. We've been working for ever since with various verticals, including defense, education, broadcasters, research institutions, the universities, oil and gas, cloud, finance, telcos, and many others. And we've really always focused on innovation and investment in R&D and providing the latest, especially high-performance compute network and storage solutions to our customers. And we also have a few subsidiaries which were spun out of XENON Systems, really as a result of projects with customers like Media Proxy, which is really a global leader in compliance logging solutions for broadcasters, XDT Catapult, which provides software solutions for the film and post-production industries for high-speed data transfers, and Synoptics, which provides fiber automation solutions for software-defined networking in data centers. And that's well illustrated a little bit in the timeline here, which shows a variety of projects over the last few years. And I really want to focus in on maybe you only have 3 or 4, which are relevant really for the topic today and which are quite characteristic of XENON standing, because XENON really is today the only DGX Elite partner in Australia, and we have that status with NVIDIA because we have been working with NVIDIA for such a long time and introduced really GPU computing to Australia together with NVIDIA. And with that, we deployed really the first big GPU cluster in Australia in 2009, which was a system, the so-called BRAC cluster for the research institution CSIRO. And at that time, it was ranked as the 10th most power efficient machine on the Green 500. We've also been working with Australian National University and the National Computational Infrastructure facility there, where we deployed the InfiniBand fabric for Australia's fastest supercomputer at that time in 2012. And also the new Gaudi system, which has just been recently deployed at NCI, is using, again, a Mellanox InfiniBand infrastructure, which we've been very closely involved in. And in between, we also provided a almost 1 petaflop performance upgrade to the supercomputing infrastructure at NCI, which was in 2017. And most recently, we've been working with customers like Harrison AI and also Consultel on deep learning and AI solutions powered by NVIDIA DGX. And as a result of this long history working with NVIDIA and also Mellanox and Cumulus, really now as all three are becoming part of the big NVIDIA family, we have a very good standing with all three of them, and we're the only partner qualified for DGX, Tesla, Quadro, vGPU, and DLI training in Australia. So enough about Xenon. Let's look really at the new technologies in the A100 GPUs and the DGX A100. So what really makes the Ampere GPU architecture as it's implemented in the A100 special is, first of all, the sheer power of the GPU itself, which is kind of underlined by just the size and the complexity of the chip itself, which includes 54 billion transistors. Where it really starts to shine is in the deep learning and AI space, thanks to the 3rd generation Tensor cores. And the A100 now makes the Tensor cores also directly accessible for other applications, which can program them for big matrix operations. In addition, sparsity acceleration now takes advantage of the structure of sparse matrices and can accelerate those as well. Multi-instance GPUs then allows to split the A100 essentially into up to 7 individual GPUs, which can then be used individually by different users for different workloads, for example, which makes the system a lot more flexible and really kind of maximizes the return on the investment because it can be used for so many different workloads. And finally, the 3rd generation NVLink and NVSwitch, which ties the GPUs in the DGX A100 then together, again, doubles the bandwidth, doubles the performance, and ties them even closer together for really big models, which can take advantage of multi-GPUs, and then with InfiniBand fabric, of course, of multiple DGXs as well. So looking at the A100 Tensor Core GPUs, so as I mentioned already, 54 billion transistors, which are manufactured in the latest 7-nanometer processor. Now it includes 108 SMs and almost 7,000 CUDA cores. We have a total of 40 megabytes of L2 capacity, and in total then a 40 gigabytes of GPU memory on the A100. The HBM2 memory there has now a bandwidth of 1.56 terabytes per second, which allows us to move a lot of data in and out of the GPU, which adds 70% bandwidth compared to the previous generation. And now we can both scale up with the 3rd generation NVLink, which doubles the bandwidth and ties the A100s in the DGX really very, very closely together, or we can scale it out with multi-instance GPU. And what's really critical for the deep learning and AI application are the 3rd generation Tensor cores, which now have additional L1 data cache shared memory and can accelerate the AI and deep learning workloads, as we'll see in the benchmarks in a few slides. So just to kind of review the specs here, for high-performance compute and scientific applications which use double precision, the performance has now increased to 9.7 teraflops. With the use of the Tensor cores, this essentially can be doubled again to almost 20 teraflops. And then we have cascading with the different number systems with the different floating point characteristics, we can go here up to more than 600 teraflops for the FP16s, for example, and where the reduced precision allows that in certain deep learning and AI models, we can go even into the petaops scale. We have now 40 gigabytes of memory available. So that's, again, a pretty big jump over the 32, which were available in the V100s. And the interconnect, as mentioned before, is now the NVLink with 600 gigabytes per second, which also doubles performance compared to the previous generation. Finally, NVIDIA has also made the transition to PCIe Gen 4, and that has been the reason why certain hardware platforms were selected for the DGX A100, in particular the AMD platform with the AMD EPYCs, which support the Gen 4 there. What's really revolutionary was the introduction of Tensor cores with the Volta generation GPUs. And now NVIDIA has further improved that by especially optimizing the floating point calculations for FP32, which are now 20 times faster than for Volta. And the best thing about it is that there is no code changes required by the end users. It really works like FP32 for AI with really a range of applications. And in particular, when we then go from FP32 to TF32, which is essentially what's called a TensorFloat format that also takes advantage of sparsity, it really works the same way as FP32 with the range of FP32 and the precision of FP16, and can therefore then accelerate the out throughput by 20x. That's already fully supported by PyTorch, TensorFlow, and the MXNet frameworks in the containers which are available through the NVIDIA GPU Cloud, which I'll also get to a little bit later. So for the user and for the data scientist, it really makes it very convenient to take advantage of these new innovations because they're already fully supported in the software stacks and the frameworks, and they're readily available as containers to install on the systems. And so this is just an illustration of how much the Tensor Core performance has improved compared to the previous generations. And so it goes anywhere from 8x to 200x, depending then on the number scheme that is used. And also for raw performance in HPC, the performance has improved by more than 2x, which accelerates any high-performance compute and scientific applications by itself without any code changes. So that's illustrated here. When we look at the top left, the HPC performance over the last 4 years coming from the P100s, the V100s, all the way to the A100s, where you can see the difference here of about 2.5x from the V100s to the A100s for here a mix of different HPC applications. Also then for the AI training, where of course the DGXs play to their strength with the AI and deep learning applications, there we see even bigger improvements, especially because of the TensorFlow 32 format, which can increase the training times on certain AI models here as shown in the benchmark by 6x compared to the V100s. And yeah, that's also shown here on the bottom right when just measuring the sequences per second for the BERT models in both training and inference. The speedups compared to the V100s are in the order of 3x to 6x to 7x. And that's really impressive improvements. The other feature that's really interesting now is that the GPUs support what's called multi-instance GPUs. That means a single A100 can now be split up into essentially 7 GPUs, which really work on the chip as 7 independent GPUs. They can simultaneously execute the workloads with a guaranteed quality of service, because it's not time slicing anymore. It is really splitting up the GPU into 7 individual smaller GPU instances, which can run in parallel with predictable throughput and latency. And now it makes it very convenient to use the A100s for training purposes, for example, with large models just as a single GPU. And for inference workloads, it can then be split up into 1, 2, 4, or 7 GPUs and run those individually in parallel with fully guaranteed quality of service. So the A100s then, of course, really need a next-gen AI system. When we look at it really from a customer and business perspective, AI provides great opportunities, but also a great threat for those who fall behind. And we see this in a lot of our conversations with our customers, where most of them are looking at deep learning and AI technologies and how they can take advantage of them in their business. And here from this Accenture survey just last year, 84% of the surveyed executives feared that they couldn't meet their growth objectives if they don't scale their AI initiatives. But at the same time, almost the same percentage there, just below 80%, is concerned and are mentioning that they're struggling with how to scale AI across their business. So on the one hand, it's the struggle for, I know I need to invest in that space to keep up with the competition, but on the other hand, the investment is really a challenge to make that work. And so what's really required to make that easier? It really requires trusted partners who can help all the way from working with talent, with personnel that's experienced in the space of deep learning and AI, both on the infrastructure side as well as then on the implementation and productization side. Of course, we also need to work with the best tools. Otherwise, the scaling is really becoming a challenge. The implementation would take too long and the return on investment would be too low. Then we need to find ways to make the models run faster, to iterate faster so that we can learn fast and again, have a leg up over the competition. And in the end, we need to make it easily accessible for the users inside the organizations so that they are not hamstrung by the technology and can move forward quickly. Previously, one of the problems has been that we had siloed architectures which had different infrastructure for data analytics, for example, for training deep learning and AI model, and for inference. And what we really need is a next-gen AI system like the DGX, which kind of combines all that in one infrastructure. And so with the DGX, we really have one system for every AI workload that includes training, that includes inference, that includes analytics. With the expertise at NVIDIA and at XENON, we can fast-track the AI transformation of our customers. We can help with the implementations all the way from the design and architecture to the on-site integration, to the transitioning of workloads, to providing consultancy for new AI and deep learning projects, all the way to productizing that and running that on the DGX platforms. And as the demand grows for these infrastructures, we can then scale these systems out, for example, in DGX pod architectures, where we can then build Mellanox fabric infrastructures to tie multiple machines together and to scale the whole system out. So what does the DGX A100 now really look like, which is the core building block for these infrastructures? We have at the core, of course, the 8 NVIDIA A100 GPUs with 40 gigabytes of memory each. We have 6 NVIDIA NVSwitches, which tie them all together. And we have 2 64-core AMD EPYC CPUs with 1 terabyte of memory, who provide the basic server capabilities of the system. In addition to that, we have some storage with 15 terabytes of Gen 4 NVMe SSDs, which provide very fast local storage. And every GPU has essentially its own Mellanox ConnectX-6 200 gigabit per second network interface. So we have 8 of them, where each of them is essentially tied to one GPU, and we have an additional adapter which can be used for external data transfers, for connection to storage, for management, and other purposes. So the revolutionary part, of course, are the A100 Tensor Core GPUs, which have 12 NVLinks per GPU. Again, that has doubled compared to the V100 and provides not double the bandwidth. We have 600 gigabytes per second bidirectional bandwidth there between every GPU pair, which becomes important for really large, tightly coupled models. And we have the PCIe Gen 4 bandwidth fabric, which ties it to the host system with the AMD EPYC CPUs. And all GPUs now are fully connected with this next-gen NVSwitch, which provides here more than 4 terabytes per second of bandwidth between the GPUs. And performance-wise, if we look here now at those 3 workloads for training, inference, and analytics, we've seen already before for training, we can get typically 6x speedups compared to the V100s with floating point 32 and TensorFloat 32 numbers. On the inference side, we can get now more than 10 petaops of performance on a single A100, which is more than 100x, here 172x peak performance. And on classic analytics workloads with a PageRank benchmark, for example, the performance there is about 13x higher than on a comparable CPU cluster. So the flexibility, especially with the MIG capabilities, which allow us to split the system up into multiple smaller GPUs and use them then for multiple developers, that allows us to use the DGX A100 for 5 petaflops of AI training power, for example. We can use it for up to 10 petaops of AI inference power, as we've seen in the previous benchmark. And with MIG, we can now also split it up and break it up into, for example, a system for 25 developers who can all share a single DGX. And now this is really the coming true, the vision of having a single unified system which can cover all the different workloads and which can be used by a whole team of data scientists all in just a single machine. And in that example, if we look at 25 developers sharing a single DGX1, each of them can have 100 teraflops of performance for training, which really corresponds to 2 reserved Cloud V100 instances, for example. And we have 25 of these developers with these capabilities on this single machine. Or we can have 357 teraops of inference performance, which compares to 6 dedicated 28-core dual CPU servers. And again, we have 25 developers who can work concurrently on a single DGX A100. That really shows the performance and the capability of this new platform. Now, briefly coming back to the networking capabilities, depending on the workloads and depending on the size of the models, would then need a lot of bandwidth to get in and out of the system, both to feed the GPUs with the data for the AI training workloads, for example, when they come from a storage system on the network, as well as then when we put whole clusters of and pods of DGXs together. That's where we need a lot of network bandwidth. And for that reason, the system includes 8 ConnectX-6 200 gig adapters from Mellanox which you can see here in the figure on the left, 4 on the left and 4 on the right for the cluster networking. And then we have a 9th adapter for storage networking, which comes by default with any new system. And we can actually install a 10th adapter optionally to provide more bandwidth to a storage solution, for example. However, the system can be configured very flexibly, and the adapters can be used for a variety of purposes, but that's really shown here what they're intended for. And XENON Systems has been working with NVIDIA for many, many years. As I've mentioned before, we've deployed some of the largest InfiniBand networks for the largest supercomputers in Australia, working very closely with Mellanox on these projects and our partners. And we have already deployed in a cluster we delivered last year that first 200 gig InfiniBand networks in Australia. So we have already a lot of experience with even the latest ConnectX-6 adapters and the 200 gig InfiniBand and Ethernet adapters and fabrics, which are available now also here in the DGX A100. So the next step then is when the workloads scale out, the workloads become bigger, the data science teams get bigger, to tie multiple systems then together in a pod architecture. That's, of course, exactly what the network infrastructure is there for. And there are complete reference architectures which are available for the pods. The advantage of the reference architectures is also that we can deploy them very quickly because they are fully tested, fully proven, and they then also include not only the network, but also the storage components. And we'll talk about that also in one of the following slides. With that, we can also get 40 petaflops of compute power in just 2 racks, where in another project a few years ago, we needed about 12 racks of CPU servers just to get to a single petaflop. And now we can do that here with the A100s in just 2 racks. And with that, we can really deploy complete architectures, complete infrastructures with the DGXs, with storage, with networking, and the services and the software stack that go with it. And we've deployed clustered architectures similar to this already for multiple customers here in the region. And we'll be able to leverage that experience also for the deployment of the A100s. So just looking at what are all the other parts now that go together with the infrastructure. Of course, for complete AI and ML environments, we need to have large data sets. They need to reside somewhere on storage systems. Then we need to develop the models and run the experiments to train the models, to test the models. They will be based on certain frameworks, depending then on the workloads. And they are all the important frameworks are available already in the NVIDIA GPU Cloud. But there's many more analytics applications, of course, which will integrate very well with the A100, including Apache Spark, Jupyter Notebooks, R for data analytics, OpenShift, and Kubernetes to manage then whole DGX cluster infrastructures. And through our work with many customers, we've learned how to design these architectures, how to build them, how to deploy them, but more importantly also how to work with all the stakeholders involved. And that includes, of course, the data scientists and the researchers who are actually going to use the systems. That includes the IT teams who we work together very closely to deploy the systems into the existing environments and integrate them. That includes, of course, the management teams who have to make the decisions about the infrastructures they want to purchase and pay for, and the DevOps teams are very closely involved in the development of the models and the productization. And so with that, XENON Systems can provide complete end-to-end solutions from consulting, deployment, through integration, and all the way to managed services, where for some of our customers, we're also, after the deployment, we're completely managing the infrastructure for them on a day-to-day basis. The challenges for the data scientists are really that, on the one hand, there's a lot of work involved in just getting the systems and the infrastructure up, and that's exactly what the DGX and the software stacks are designed for, to make that really easy, reproducible, and fast to deploy. On the other hand, there, of course, are all the data science tasks to actually develop the models, to test the models, to run the experiments, and then to deploy them. And the real challenge is, how can you, as a company, as a customer, make sure that you get the most productivity out of your teams and not have them work on tasks which are not directly related really to their jobs. And especially in data science, the challenge is that a lot of teams who go out, strike out on their own and build their own infrastructures, they have to take care of the hardware platforms themselves. They have to orchestrate their systems. They have to look after their schedulers. They have to manage their containers. They have to manage their tools, their frameworks, and very often deploy them, compile them themselves, and of course manage their models, repositories, and everything else. And so we see very often that the time spent on actual data science is smaller than the time spent on getting the infrastructure up and running, managing it day to day, and just being able to have the tool set available to actually then do the data science. And that's one of the challenges that we try to help with by designing the right solutions, deploying the DGX systems, taking advantage of all the frameworks and containers which are already available and which can get us up to speed a lot faster. And as mentioned before, some customers take advantage of that all the way to fully managed solutions where XENON Systems staff will manage the systems also day to day and essentially take away the majority of that non-data science work so that the data scientists in the teams with our customers can really focus on the data science and not on managing the infrastructure. So looking quickly at the software stack, it's really based on a host OS, which is a derivative of Ubuntu with the NVIDIA drivers and the NVIDIA Docker containerization tool on top of that. And then there's a variety of both deep learning frameworks, and most of them are open source anyway, as well as third-party accelerated solutions available in the NVIDIA GPU Cloud, which will make it very quick and easy to deploy them. And all of that really is designed for performance and manageability. The host OS, and especially the drivers and libraries, are of course optimized for multi-GPU performance. The driver and library independence is guaranteed for every framework. All the popular deep learning frameworks are tuned by the NVIDIA engineering teams. They are frequently updated, uploaded into the NVIDIA GPU Cloud, and available to be pulled by the customers directly from the NVIDIA GPU Cloud to pull onto their systems so that they can take advantage of the latest improvements. And we've seen that recently with one of the applications, for example, Parabricks, which is a genomic analysis tool, which just by software improvements itself has seen performance improvements on the order of 30%. And then we get another about 2x performance improvement coming from B100 to the A100s. And that's all without requiring any code changes on the end user on the customer side. Of course, there's also focus on maximizing productivity with a minimal setup time, and that's why the whole software stack is fully pre-configured and pre-optimized. The operating system image itself is really kept to a minimum, and everything is containerized in Docker containers to make it very easy to upgrade and deploy. And also, all the software and security updates are non-disruptive and won't have any effect on running applications. And so just to mention on the NVIDIA GPU Cloud, it really includes a lot more than containers nowadays. It also includes complete models, which can be easily downloaded and used right away. And it also includes Helm charts for complete deep learning workflows. It's also possible to deploy private registries with access controls, with scanning, signing, and encryption, and a complete lifecycle management for containers. And the containers then can be deployed anywhere. And that includes the on-premise installations on the DGX A100, for example. The very same models can also then be run in the cloud. And once the models are optimized, they can also then be run using the same containers on the edge devices directly in the field. And XENON Systems has a lot of experience deploying its own workstations for development and test, for example, with the exact same software stack and the available containers from the DGX NVIDIA GPU Cloud. Of course, all the DGX 1s, 2s, and now the DGX A100s are running the containers from the NVIDIA GPU Cloud, the complete DGX pod architectures, and also custom cluster solutions can run the very same containers, which makes it very easy to move from one system to another. And also, there is now a stack of DGX-Ready software partners, which have cluster-first platforms, and then their software is optimized for pod-like cluster architectures. They run on top of or integrate well with Kubernetes as the container management platform on top of multiple DGX systems. And here on the right, you see some of the applications and the projects which are DGX-Ready software partners there. This way, we have complete AI workflow features for interactive sessions, for data-centered experiment measurements, and flows all the way to production deployments. And again, with the integration with the NVIDIA GPU Cloud, they are compatible with on-prem deployments, and the NVIDIA GPU containers, which are regularly updated and optimized, can then be run within these platforms. So to look at how can XENON Systems help you now directly? And we've looked at that on one of the earlier slides. What are all the components that are required to really help you through that AI journey from the data science teams, from the initial design and architecture, all the way to scaling it out to larger systems? XENON Systems can help with NVIDIA DLI workshops, which we're delivering with experienced XENON trainers. And we can also provide consulting services with a network of world-class AI experts. We need the best tool for the job, and that includes high-performance workstations for development and test, like the XENON DevCubes. Of course, the data center solutions like the DGX A100, edge devices like the NVIDIA EGX, and embedded devices like the NVIDIA Jetson. And we have customers using all of these solutions fully integrated, pre-configured, and deployed by XENON Systems. For DGX pod architectures, we can then integrate with large storage systems, with high-performance network fabrics. We have years of experience deploying storage solutions, be it flash, drive, object storage solutions for large capacity, tape, and also cloud storage. And as I've mentioned before, we've been working for many years with Mellanox on deploying InfiniBand and Ethernet fabrics, and now, of course, also with Cumulus as the switch operating system to make that all very seamless and very quick and efficient to deploy. And you see some of our storage partners here listed on that slide as well. And finally, of course, we can deploy also DGX SuperPod architectures. These are complete scale-out multi-rack designs, which can scale to pretty much any size. And as we've done in the past, we can also design complete custom cluster designs and integrate them into existing environments or deploy completely new greenfield solutions for complete GPU accelerated cluster architectures. With that, I'll wrap it up here. You have our contact details, and in particular, John's on here as well. So if you're interested and want to follow up with us later on, please contact us here at these email addresses and phone numbers, and you also have our web address there where you can find further details. So with that, I'll thank you very much for your attention and open it up to questions.
That was awesome, Werner. Thanks. Look, we've got a couple of questions that have come through on the chat. The first one deals with the multi-instance GPU. And the question is, how is the memory allocated when you slice up the GPU into those multi-instances?
So we have a few different options how we can slice up the GPU in kind of either just one single A100 or 7 small ones. Also, there's smaller instances with kind of having 2 of the smaller GPUs together or 4, and the GPU memory goes correspondingly with that. So this total of 40 gigabytes of memory is also then allocated correspondingly to these smaller GPUs. So that way, when we then have 7 MIG instances, they will have their correspondingly smaller memory associated with that. But that's really the only way how then the quality of service can be ensured, because then each really small instance of a GPU slice has its own memory available. And yeah, that's how the MIG is implemented, and that's how it can really fully guarantee the quality of service.
That makes sense. So it scales up and down. We've got another question here. Is Xenon offering DGX rentals for short-term projects? Is that something that we've got on the go?
So right now we see a lot of demand for the A100s, and we actually have challenges just getting NFR units ourselves, because people are really just kind of buying them directly as they are, and production is just trying to keep up with that. So at this point in time, we do not have rentals available. If there is interest in that, in the option of looking at A100 based solutions, yeah, I would suggest follow up with us separately, and we'll see what solutions we can come up with to work with you there. Okay. Apart from rentals, of course, there are also financing solutions available to make that work with corporate budgets, for example. So we're used to working on a project-by-project basis, how to find the optimal solution for you.
Fantastic. Probably leads on to the next question too, in that someone's asking here, what's the power and cooling requirement for one of these?
Right, so each DGX A100 consumes about 6.5 kilowatts of power at full load, and that's of course what the systems are designed for. And so before we deploy any DGX A100, we have essentially a structured questionnaire that we work through with every customer to make sure that we can meet all the requirements for the successful installation of the system. And so that includes not only the electrical power, because we also, of course, need suitable PDUs and the suitable power outlets. That also then includes the corresponding cooling that needs to be available in the data hall, and specifically in the rack and in the rack location, which also varies from data center to data center. We also take care of the complete delivery and the on-site installation in the rack. And so the power requirements is kind of one small aspect of really the whole delivery services that we are providing with every system when we work on such a delivery. And that goes way beyond power and cooling there. That goes to the installation in the racks, that goes to the network integration, And of course, then, depending on the project, also the storage and other networking solutions and integration with the end user's IT environment.
Fantastic. All right, well, I think that pretty much wraps up the questions and this Xenon Tech Talk on the NVIDIA DGX A100. Thank you so much, Werner. It was really insightful and informative. And I'd like to thank everyone who attended. Really great turnout. It was really great to see everyone here today on the webinar. Thank you so much for your time and for tuning in to this Xenon Tech Talk. You'll receive the recording shortly on your email. Feel free to share it with your colleagues and follow up with us if there's any questions or any discussions you'd like to have. Contact Werner, myself, or your Xenon account manager. Thank you so much.
Thank you, and we'll be in touch hopefully soon.